Welcome you all for this discussion on case study approach for the topic smart sensor interface circuits in IoT application. So we are going to discuss about the smart sensor circuits which are essential in IoT applications, like collecting the output from the environment like pressure, temperature, air quality, humidity, etc. So these data are physical quantities. This physical quantity to be converted from analog to digital signal. So we need interface circuits to convert this data for signal conditioning like filtering, amplification, and also digitization, noise reduction, calibration. So these should be implemented in interface circuit before processing the original signal. So you are going to discuss and analyze the sensor circuits which can be implemented for temperature monitoring systems like home automation, agriculture, and healthcare devices monitoring. Okay.
Problem background. So IoT devices often face challenges when deployed in real-world environments. Sensors usually produces weak analog signals which is not directly readable, and sensors are non-linear characters, so this it requires a calibration, and many sensors should be connected to a single sensor should be connected to a single microcontroller pin or ADC channel. And so let's we move to the so the objective is to analyze and design a smart sensor interface circuit which uses the IoT devices, and which improves the efficiency and readability and the reliability of the IoT devices such as temperature transmitter or LM35.
We see about the components of smart sensor interface circuits: sensor elements, signal conditioning unit, amplification, signal conditioning unit amplification, linearization, filtering, etc. ADC, analog to digital converter, which converts physical quantity to digital values, and microcontroller act as a calibration and compensation.
For this, we consider a scenario for this case study. First, we have to remember a house where we control the fan, AC units, and heater. In this, we need to use this temperature to control this. So we use sensors like LM35. LM35 only reads about 10 millivolt for 1 degree Celsius, but it's easily disturbed by electrical voice. So for we need to remove this electrical noise, we use a OP amplifier for this. So it will remove the noise from this LM35. And after we remove the voice, we use filter for this we use amplifiers to make that LM35 signal stronger, so it can reach to the microcontroller easily. And then the second step is we use a filter for this, because LM35 was easily affected by the electrical noise, so we use filter to remove that noise. Then third we have to use a calibration network. Calibration network means that LM35 sensor may have a manufacturing defect, so to remove that manufacturing defect, we use the calibration network for that. Then here comes the smart part, where we use IoT simulation to detect the temperature in our room to control the fans, AC, and heater. In that IoT simulation, we use Blink and Firebase software to implement the voltage we receive from the microcontroller. If the voltage is like 3500 millivolt, means we receive 35 degrees Celsius. So with that voltage, we use IoT simulation like Blink and Firebase. So we can see our temperature in our phone and app, and we can make our room comfortable, and we can also save the electricity.
Very good.
I will be explaining about the interface circuit, that is IC, used in IoT applications like electronics and everything you do. The usage of interface circuit in IoT applications makes stable temperature readings, and it gives a faster response, and it also gives accurate ADC values with minimal microcontroller processing load, and it also gives minimal noise fluctuations from the microprocessor. These are the advantages we have with the interface circuit implemented in our IoT applications. Without this IC interface circuit, the disadvantages are exactly the vice versa. That is, for example, for temperature readings, you get high error at low and high temperature, and it also gives fluctuating readings, and all these lead to unstable IoT response. For example, AC or fan switching at the wrong time, and that's it.
We are going to discuss that small interface circuit makes a simple sensor intelligent. They improve accuracy before the signal is digitized. They reduce the burden of computation in microcontroller. They enhance noise immunity, critical in IoT. Devices were deployed in out industries like house. With low power design, battery life increases significantly for portable IoT nodes.
You have discussed a case study on smart sensor circuits which is used in IoT application. So it is necessary for increasing the accuracy, reliability and efficiency of an IoT system, where we need to deploy in smart automation like temperature monitoring in home and also agriculture devices. So you have given the exact details of ADC, microcontroller, noise reduction, filtering and calibration. So these are all the essential parts of an interface circuit in IoT application. Thank you for discussing your ideas. Thank you all.